Good evening, ladies and gentlemen, and welcome to the Arvin Gottlieb Planetarium live shows. We know many of you have been watching these programs over the last several months, but I wanted to take a moment to say thank you for your support and bring you up to date on what's happening at your Science City. We've been closed for nearly 8 weeks, and we've had no revenues from our attractions here at Science City and Union Station. But we continue to put all these great programs online. It's becoming challenging. We know you enjoy this program, but I'd ask you tonight to join us in donating and supporting this magnificent facility, but more importantly, the great staff that has been bringing programming into your home, just like Patrick. So tonight, enjoy this program, learn, and take an opportunity to just press that button and make a donation to Union Station and the great team at Science City. Over the next few weeks, enjoy all of the programs that we have at Science City at home. We thank all of our sponsors, and especially tonight, enjoy the programming of the Arvin Gottlieb Planetarium. And we thank our friends at Arvin Gottlieb for investing in bringing this great institution to Kansas City. Now, I know you've enjoyed the several weeks of the programming, but it was all made possible by a dedicated team at Science City and, of course, an outstanding educator that brings the stars to Kansas City. Ladies and gentlemen, please welcome Patrick Hess.
Thanks, George, for that great introduction, and thanks everyone for tuning in to another Planetarium live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station, and I'm very excited to have you all joining us today on this sort of cloudy Monday evening. I wanted to give another special thanks to our 10,000 Union Station member households who keep supporting us and help make these events possible. As George mentioned, supporting these live online programs is really important and really easy. In fact, you can click a donate button you can see on your screen. If you're streaming from any of our Facebook pages, you should see that donate button. We have invested millions of dollars in all the facilities and technologies in Science City and in the planetarium. And all of us, especially myself included, can't wait to welcome you all back in person. But in the meantime, we really appreciate all of your support online, and every dollar really does help out. But we are going to go ahead and jump into our live stream. Now, if you're joining us for the first time, I'll give a little introduction. If you're joining us for not the first time, welcome back. Thanks for sticking with us and checking out all our different streams. But if you're a new watcher for our live streams, let me explain briefly about how this works. We stream on Mondays, Wednesdays, and Fridays at 6 p.m. From this same location. As you can see, we have a different backdrop if you're tuning in again. We are streaming from the Tarantula Nebula today. But the way our schedule works is that on Mondays, we'll be doing a tour of the night sky. It's our What's Up live stream where I'm going to be showing you different stars and constellations you'll see this week to give you a primer for stargazing for the week, assuming the weather holds out. Wednesdays is our special deep dive live stream where we take a deep dive into a specific topic in astronomy. And some of these topics we've covered so far have included the solar system. We've gone through a full tour of the solar system, all the major and many minor bodies in the solar system. We've talked about stellar evolution, the life cycles, and how stars are born and how they die. We've looked at the Messier catalog. We've learned about probes and rovers. And if you missed any of these streams from our previous Wednesday deep dives, you can find recordings of all of our streams on any of our Facebook pages. That's the Union Station Facebook page, the Science City Facebook page, or the Arvin Gottlieb Planetarium Facebook page, which, by the way, if you're not subscribed to us, be sure to like and subscribe there. And then Fridays is our Fan Friday, where we answer your fan questions. You're welcome to throw in your questions in the comments for all the video streams on Mondays and Wednesdays, and I'll do my best to answer the questions that are relevant to the topics I'm covering. But more than likely, we'll be covering those questions on Fridays. We'll make sure we write those questions down if we miss them earlier in the week. And then on Friday, we go off script, basically. I don't have an outline, and we just talk to you all, and it's a nice sort of one-on-1,000 conversation with everybody who's watching from the ether, and I just answer your questions live, and it's a great discussion, and we learn a lot about space, and sometimes I even learn something new, which is my favorite thing. So that's what the deal is, Mondays, Wednesdays, and Fridays. Just a little teaser for this Wednesday. I mentioned it last week, but if you didn't hear, this Wednesday's deep dive live stream is going to be about telescopes, and we're going to shuffle around our pocket dimension here, and we are going to I'm going to have to change my camera setup a little bit because I'm going to teach you about the technologies and techniques behind telescopes. I'm going to be setting up my telescope, which is a reflecting telescope with an equatorial mount. But if you have any other telescope that's been sitting in your garage or attic gathering dust, you'll still learn a lot about telescopes, even if it's not the exact same kind. So tune in then. I'll walk through how to put it together. Like I said, we'll sort of zoom out a little bit and you'll be able to see that in detail. Then I'll talk about how to use telescopes. So Wednesday at 6 p.m., don't miss that, and dust off those telescopes you have lying around if you want to learn how to use them. Another thing I like to do on Mondays is kind of go through recent news that happened in the world of space exploration and astronomy. There are some fun and interesting news pieces that happened. Let me see if I can load them up for you to see. All right. Yeah, so let's switch over to our other camera. So a big piece of news that came out a few days ago was that NASA announced that they had selected 3 different companies who will lead their current plans for returning to the moon. This is exciting, and over the past few decades, NASA has had various plans to go back to the moon, and those have shifted based on changing political regimes. But this is the most recent plan that was just announced, and the plan is for 3 different companies, Blue Origin, Dynetics, and SpaceX, to develop, launch, and land their first landers, their first manned landers, or human-personed landers, I guess, on the moon by 2024. So that's not too far away. So assuming all the funding stays consistent and there aren't any big setbacks, these 3 companies may be sending people back to the moon in the next few years, which is pretty exciting. Blue Origin, this company is actually partnering with a lot of other companies that are sort of old standbys for space exploration, like Lockheed Martin and Northrop Grumman, who have been a part of aerospace technology innovation for decades. Dynetics is a new company which I'm actually not very familiar with, so I'll have to do a little more research there. But they are based out of the States. All 3 of these companies are domestic companies. And then SpaceX is a private space company that has been in the news a lot for pushing the reusable rockets, and their plan is to launch possibly their super heavy rocket booster there, and then in this picture is actually their Starship rocket, which they recently announced the naming, and they're still building and testing it. But anyway, so pretty exciting that NASA has announced their official plans to essentially go back to the moon, and that could be in the next 4 years. Another fun piece of astronomy news that happened, or that came out recently, is scientists were studying the landing site for the Perseverance rover. I talked a little bit about Perseverance, which is the Curiosity Mars rover's sort of younger sibling that's planning on being launched to Mars this summer, later in the summer. If you want to learn more about those rovers, check out our live stream from last Wednesday, which was all about probes and rovers. So scientists have been studying the landing site, which is the Jezero crater, and basically they have been observing this crater, which we've known to have these dried riverbeds. But they basically studied the riverbeds in particular and found out that the rivers were flowing for a lot longer than they previously thought, which could mean that this location potentially could be a place that would have supported life on Mars better than most places. If there was a source of water flowing consistently for a long period of time, this could be a great candidate for a place that, if there is or ever was any life on Mars, there's a good chance it would be in a place like this. So the Perseverance rover is going to be landing in this crater, and this will be one of the spots it's going to be exploring over the next few years, so stay tuned for that. Could be exciting stuff in the works and exciting discoveries happening. So those are the big news factoids that I wanted to bring up. And just a quick reminder that on May 27th, there's a big space launch happening. NASA, for the first time in about a decade, is going to be launching American astronauts aboard an American rocket into space. They're going to be riding the SpaceX Crew Dragon capsule to the International Space Station. And that is the first time since the Space Shuttle program that Americans have sent our own astronauts to space. We've been hitching rides with other space agencies since then. So May 27th, that's a Wednesday, we'll be talking about that launch, as well as other historical, we'll be talking about the story of SpaceX, as well as the history of human space exploration on that Wednesday deep dive. So May 27th, mark your calendars for that launch. The launch itself, I think, will take place around 3 p.m. and we'll be posting a link to a live stream that SpaceX will be hosting, so you can follow around that, follow along during that launch in real time. All right, so let's just jump on in. I'm just checking to make sure if there have been any questions yet. Just want to make sure I can tell the ones apart from last week. I think we got a question. I can't tell if this is from last week or this week, but Kristen was asking when the Dragon capsule is going to launch, and again, that is on May 27th. Okay, so let's go ahead and jump in to our main scheduled programming, which is our Star Tour. So we are returning to the Stellarium software. This is a free piece of software you can download and use at home, and it's basically a virtual planetarium. I've altered our software to give us a nice view of the Kansas City skyline. So it's just like you are standing right here on the Liberty Memorial at the World War I Museum and Memorial, with the Eternal Flame behind us towards the south. The sun setting in the west. Of course, I don't know about you, but I cannot see the sun right now through my windows. It is a cloudy day. How about that storm this morning, too? But fortunately, with the power of our digital planetarium, we can see an unobstructed view of the sky. So our star tour begins in the daytime sky because the sun is our daytime star. It's shining over in the west, but it is setting earlier. Now, as the days get longer, the sun will be setting later and later. Right now, the sunset will be happening around 8 or 8:30. But we're actually going to be fast-forwarding time past the exact point of sunset, because even when the sun goes below the horizon, it is still pretty bright, and that twilight remains for a while. So we usually wait about an hour after sunset. So we're fast-forwarding time here, and we are going to spin our star tour, right around, let's go all the way over to about 9:30. And here's our evening sky. Now, this is the night sky that you will see. This is not the night sky you'll see in downtown Kansas City. In our simulation here, I was able to flip a light switch that turned every street light and building light and car headlight off, which gave us an unobstructed view of the sky in our virtual planetarium. But the truth of the matter is that when you're in downtown or near any other civilization or big city or even the suburbs, it's pretty hard to see the stars. This light pollution comes from many man-made light sources, like I mentioned, and all those extra light sources shine light up into the sky, which bounces off our atmosphere, and it causes the sky to kind of glow near the city. So in reality, you would not see this many stars from this exact spot downtown. But luckily, here in the Midwest, you don't have to travel far to see a view of the night sky like this. If you drive about an hour away from town, towards the west especially, you'll get a nice view of the sky, and on a clear night, you may even be able to see around 2,000 stars with the naked eye. But for our virtual planetarium tour, we are going to be giving ourselves a virtual sky, because why not? We can do whatever we want, right? So let's go ahead and start in the north. Now, if you've ever watched one of my star tours or tuned into a stream before, some of this stuff is going to sound familiar, but I always like to start from a familiar place so we can all get our bearings and we all know what we're looking at. And if you're tuning in for the first time, you may not have heard this. But I always like to start my tours with two very familiar patterns. They look like two big spoons in the sky. The first one looks like a little spoon right here, and the other one is a bigger spoon above it. And these are the Little and Big Dippers. Now, the Big and Little Dipper are actually not technically official constellations. And I should talk a little bit about constellations. What are constellations in the first place? Well, a constellation is a group or pattern of stars in our sky, and there are officially 88 of them. These were picked and officially sort of signed into the Book of Science, I guess, back in 1930 by an organization called the International Astronomical Union. That's the same group of people who recently demoted Pluto, so let's all thank them for that one as well. 42 of these patterns are animals, 29 are inanimate objects, and the other 17 are humans or characters from mythology. And we'll be looking at a bunch of these throughout the tour. But 88 is not a whole lot, and like I said, on a clear night you can see 2,000 stars with the naked eye. And it stands to reason that people around the world probably saw more than just 88 shapes up there in the sky, right? So we group this night sky into two different categories. There are the official constellations, which are those 88 patterns, and then there are these things called asterisms. And an asterism is basically just an unofficial pattern. A group of stars that's famous and well known, but is not one of those official 88. So the Big and Little Dipper are two asterisms. They are not official constellations. Now these stars are part of two official constellations. The constellations are named Ursa Major and Ursa Minor, which means the Big Bear and the Little Bear. I'll teach you how to find the Big Bear. Its stars use the Big Dipper, as you might guess. It's upside down right now. The tail of the bear is the handle of the spoon. The body of the bear contains the spoon, plus these two stars. The head of the bear goes over to this star, and its legs extend up into the sky. Like I said, it's upside down this time of year. Again, there's the tail, the body, the head, and the legs. And we can see that bear shape. Now, a question we've gotten in the past is, why does this bear have a long tail? After all, bears generally do not have long tails, and we can see Ursa Minor, the little bear, has a similarly long tail. Now, there is no exact reason that we know of for why these bears have these long tails. It's interesting, though, because there is recorded evidence dating back thousands of years of different people and cultures seeing these patterns as the same bear figures. But, you know, perhaps even distantly in the past, there were translation errors that, you know, there's evidence that some Native American cultures saw these as raccoons, and there could have been a translation error between that and a bear. So we don't really know. But there is references to bears, like I said, dating back thousands of years. Let's go ahead and hide those here. Now, I'm highlighting a star here, actually, on accident, that is a very important star and a very famous star. Its official scientific name is Polaris, but it has a much more famous nickname you might be familiar with. We call it the North Star. Now, Polaris, the North Star, is very famous and important, but perhaps not for the reason you might think. For example, it's not the brightest star in the sky. This is a common misconception, but Polaris is not brightest. It is actually the 45th brightest, so it's not even anywhere close. To really understand why it's special, we will have to stay up a little bit later in the evening. So if we fast forward time again, from this vantage point, you might have noticed earlier that the stars don't stand still throughout the night. They will actually slowly move. And as we start fast forwarding time, you might start to notice them moving. And they move pretty slowly, but you can see that in the east, they are appearing to rise from this direction, and in the west, they're appearing to set in this direction, just like the sun rises in the east and sets in the west. Now, the sun and the stars aren't actually spinning around us, of course. It's the Earth that's spinning, and as the Earth rotates around its axis, our viewpoint changes. So this is just what it looks like from our perspective as we ride the Earth as it spins around. But that North Star is interesting. As you can see, it is not moving. It's actually the only star that doesn't move. It stays in the same place all night, so no matter where you are on planet Earth, no matter what time of night it is, if you can find the North Star, you can always find north, because the North Star always points north. Let's bring ourselves back. Woo! A little bit too fast. There we go. We're going back to our star tour time, about 9:30. There is a nifty trick you can use to help you find the North Star if you're having trouble. Just take these two stars at the end of the spoon in the Big Dipper and draw an imaginary line through them, and this time of year they'll point down towards Polaris. If you can't see the Big Dipper, or if it's in the winter when the Big Dipper's lower in the sky, you can use another pattern of stars to find it. It is a constellation below Polaris right now that looks like a little W or a zigzag. This constellation's name is Cassiopeia. Cassiopeia, this W shape sort of is open towards Polaris, so that's another way you can find it. Speaking of Cassiopeia, there's another constellation that goes along with it that is part of its story from mythology. This little house-shaped constellation next to it. This one's called Cepheus. In mythology, Cepheus and Cassiopeia were the king and queen of an ancient African nation. The queen Cassiopeia was very beautiful, but she was also very vain. She liked to brag about her beauty. One day Cassiopeia boasted that she was more beautiful than the daughters of Poseidon, the god of the sea. When Poseidon heard about this, he was not very happy, as you can imagine. A mere mortal claiming she was more beautiful than his immortal daughters. He could not let that stand, so as punishment he cursed their land with years of flooding, which washed away many of their crops and sent their kingdom into a terrible famine. In order to try to appease the god Poseidon, Cepheus and Cassiopeia tried to offer him a gift. They gave him their own daughter Andromeda. They actually tied Andromeda to some rocks by the ocean so she could be eaten by Cetus, a giant sea monster and one of Poseidon's other children. But luckily for Andromeda, the story has a happy ending. She was not eaten by the sea monster as an offering to Poseidon. She was rescued by a hero named Perseus, which is a constellation we can find right next to these two. I guess I can turn their names on, that would help. So Perseus rescued Andromeda, and he defeated the sea monster. Perseus was actually the famous Greek hero that defeated the monster Medusa, and it's said that he used the head of Medusa to turn the sea monster to stone as he rescued the princess. So we're going to move right along towards the west. Now, in the western horizon, even earlier in the evening, before the sun has finished setting, you might notice a very bright point of light standing out amongst all the other starlight. It'll be the first point of light you'll see tonight, and it'll be so bright you'll even see it in the daytime sky before the sun finishes setting. You might think that this is just another bright star. In fact, it's often nicknamed the evening star, but it's actually not a star. And you can tell very easily by comparing it to other stars around it. If you compare this point of light to stars nearby, you'll notice that stars are twinkling. They twinkle here in our simulation just like they do in the real night sky, but you'll notice that this point of light is not twinkling. Now, the reason that stars twinkle is because they're very far away from Earth, and it takes a long time for a distant star's light to reach our planet. By the time a star's light does reach the Earth, only a tiny amount of it is able to pass through the Earth's dense atmosphere, and our atmosphere causes that little bit of light to become distorted, making it appear to wobble and twinkle. That's why stars twinkle. But this point of light is not twinkling because it's much closer than distant stars, so a lot more of its light is reflected back towards Earth, and it actually appears as a wider disk of light, so more of its light is able to pass through our atmosphere and it's not disrupted, which is why it doesn't twinkle. This is a planet. There's actually another way you can tell it's a planet. It won't be in the same place every night. Planets appear to wander around our night sky as they orbit the sun at their own pace. That's actually how they got their name. The word planet means wanderer in ancient Greek. And this wanderer you'll see in the west tonight. Well, maybe not tonight if you're in Kansas City because it's so cloudy, but this season is Venus. Now, to the naked eye, it still looks like a tiny speck of light, but we have a planetarium handy, don't we? Let's zoom right in here and take a closer look at our sister planet Venus. Now, although Venus will be the brightest point of light tonight, as we zoom in, you'll notice that only a crescent of it is actually visible. And if you looked at Venus through a telescope, this is what you'd see. But Venus is incredibly bright because of its dense atmosphere, which reflects a lot of the sun's light. And even in this crescent form, it's still very, very bright. Now, Venus appears in a crescent, and this is kind of unique. In fact, Venus and Mercury are the only planets that do look like this in our night sky, or they are the only planets that can look like this, because they're closer to the sun than the Earth is. So Venus and Mercury can be in a position where we are able to see them from this angle and see their phase, sort of like the moon has phases. Planets that are farther away from the Earth, like Mars, Jupiter, and Saturn, we don't see them in crescent phases. We might see them slightly shadowed, but because we're always looking at them from an angle where they're facing the sun, we don't really see this sort of crescent phase. Now, Venus won't be around for much longer, so I would encourage you to try to check it out. As the year goes on, Venus will be setting earlier and earlier. Sometimes Venus will appear in the early morning sky, and then it's nicknamed the morning star. Again, it's not a star. But that just is its nickname based on when it often appears. And it will always appear in the early morning or early evening because it is closer to the sun, so it always looks to be relatively close to the sun in the sky. So you'll never see it at midnight. Nearby Venus, we've got a few interesting constellations. Right over here is Gemini the Twins. This one's a fun one to spot. Looks like two stick figures holding hands. These two bright stars are the stick figures' heads. Here's one head, his body, arms, and legs. Here's the other head, his body, arms, and his legs. They're kind of short and stubby. These twins were named Castor and Pollux, and they were a famous pair of Greek heroes. We can move along to our southern sky, where we will see Leo the Lion shining right behind the eternal flame here. You can find Leo using another asterism. This one looks like a question mark or a coat hanger hook. This is Leo's head and his mane. Here's Leo's body, his front paws, and his tail. Sort of looks like he's lying down. I did see we just got a question from Eric asking why Venus is so bright. And I started to mention a little bit earlier, but Venus has a very, very dense atmosphere. It's covered in pretty much entirely in clouds, and those clouds are incredibly reflective. So Venus is just like a giant mirror reflecting all that sunlight. Let's move right along to a constellation that is right near the moon tonight. And actually, let's talk a little bit about that moon. Let's zoom in on it. Tonight's moon is a waxing gibbous phase. Waxing means that the moon is currently getting bigger and brighter, and gibbous means that the moon is more than half full, but it's not quite completely full. There is a full moon scheduled for this Saturday on May 7th. That's not Saturday, Thursday. Did I mention that time has no meaning anymore? Thursday, May 7th, is going to be a full moon. Now that does unfortunately mean that this is not a great time for stargazing. Besides it being very cloudy, the moon is very bright and it actually causes a lot of light pollution. So the moon is going to drown out a lot of the surrounding starlight. But after May 7th, when the moon starts to wane, it'll start to rise later in the evening and you'll have better chances for some good stargazing. But the moon is kind of right in the heart of another constellation called Virgo the Maiden. She looks like a big stick figure. This is Virgo's head. Here are her arms. Here's her body and her legs. Virgo represents a goddess of fertility or harvest. The Greeks called her Demeter and the Romans called her Ceres. She's often depicted as showing holding an ear of grain in one hand. In fact, the star in Virgo's hand is named Spica, and Spica means ear of grain in Latin. Now, these constellations that I've shown you belong to a famous group of constellations. There are 12 constellations in this group. They're called the constellations of the Zodiac. Now, these constellations circle our celestial sphere, so you only see certain ones during certain times of year. Cancer the Crab is another one. Taurus the Bull is one that is setting over here. So as you can see, not all 12 of them are visible right now. These constellations are more famous in astrology. Astrology is the practice of using constellations to predict things about people, like your horoscope or your personality. There's not much science to it, but it is a fun hobby for some people. In astronomy, these constellations are closely related to a plane, or a marker, or sort of an imaginary line that goes through the sky called the ecliptic. So this central line right here is the ecliptic. And this line marks out the plane of our solar system. So all of the planets in our solar system sort of orbit in a flat disk. They all orbit parallel with each other. For that reason, if we saw the sun in the daytime sky, the sun is actually going to be appearing along that same plane, if that makes any sense. So I guess I can, maybe let's check that out. So if we rewind time here, we will see that the sun is appearing near this ecliptic plane. That's not the ecliptic plane. That is. There, that's better. So the sun is right there on the center of this ecliptic line here. And all these constellations are as well. So as the Earth orbits the sun will always be right along that line. And that means that the sun will always be in front of one of these constellations, because these constellations are lined up along this ecliptic. I don't have my visual aid with me right here, but I've used it to explain in previous star tours that, you know, the stars are, you can imagine them being around the Earth in a celestial sphere, but they're not perfectly, they're not the same distance from each other. Different stars are further away than one another, but you can imagine that what we see in the night sky is sort of a ball of stars around us, sort of a globe of stars. And the whole solar system is inside that globe, right? And so that flat disk is inside that globe. So if we extend all of the orbits of the planets out towards that disk, they would line up with these 12 zodiac constellations. That's what the ecliptic is. And that's why in the daytime, the sun will appear on the ecliptic as well. This is just our perspective. Since we are on Earth looking at the sun, we are sort of looking at the plane of our solar system as well. And so all the planets' orbits will follow the same line. Now in astrology, they say that the sun is in the house of your constellation on your birthday. And that means that literally the sun is in front of that constellation on your birthday. So the zodiac constellations really have nothing to do with the nighttime sky in astrology. It's all about the daytime sky, whichever constellation the sun is in front of. So as you can see right now, the sun is kind of between Taurus and the next constellation in the zodiac line here. Excuse me. Whew. I think that was my first on-stream sneeze. Let's go back over to nighttime. Excuse me. Whew. Hope I didn't sneeze right in the microphone. All right. Now, I told you that Venus is the brightest point of light in the night sky tonight, but the brightest actual star you'll see is this one over here. It's named Arcturus. Arcturus means Watcher of the Bear in ancient Greek, and it's part of a bear watcher constellation called Boötes. Wow. Still getting the hang of these controls here. Well, it's not wanting to only show that, but Boötes kind of looks like a ice cream cone that's sort of spilled over. Now, Arcturus and Spica have a nifty little trick you can use. There it goes. To remember them by. You see the handle of the Big Dipper nearby over in the northeast? It's sort of shaped like an arc. Well, if you extend that arc across the sky, it points at and passes through these two stars. And there's a little saying you can use to remember this. Just remember arc to Arcturus and speed on to Spica to remember how to find these stars. Once again, just arc to Arcturus and speed on to Spica from the handle of the Big Dipper, and you can easily find and remember these two stars. Now also, I didn't mention it before, but the star at the end of Leo's tail is named Denebola, and Denebola means tail of the lion in Arabic. And this star actually is often connected to Arcturus and Spica to form a great triangle in our spring skies. This triangle can be seen high overhead for most of our springtime evenings. And as you might imagine, astronomers were very clever and original when it came to naming this triangle, famous for our spring skies. They decided to call it the Spring Triangle. Now, this is an asterism that ancient people used to help them figure out the changing seasons. The way this works is that in the winter, you'll see these three stars rising one after another, but as soon as you see all three are up after sunset, that tells you that spring has arrived. Now, there's a famous asterism for the summertime called the Summer Triangle, and its stars are a bit brighter, so it's a bit more famous. In fact, we can already start to see the stars of the Summer Triangle beginning to rise towards the northeast. Vega is the first star we'll see in the Summer Triangle, and over the course of the next few months, the other two stars will be rising earlier, and once all three stars of the Summer Triangle are up, that tells us that summer is here. I got a question from Eric asking, will the ecliptic shift over time like the magnetic poles? And the answer is yes, but the ecliptic itself won't really shift, as in the positions of the positions of the, well, actually, hang on, let me think about this a little bit more. So one thing is going to shift over time that'll change our perspective on the stars, and that is the axial tilt of the Earth. So I wonder, actually, I have a visual aid I can use. Let me show you. Okay, so let's go back to our first camera here. So the Earth is spinning around on its axis like a top, all right? And I have a top right here. And let me see if I can do this on stream. So when you spin a top, it spins around really quickly. I'm trying to think if I've got a better tool that will, you know what? Let's try my water bottle. Let's hope it doesn't drip on my computer. So if I spin this top, there we go. You can see it spins around really, really quickly, which keeps it balanced, but then it also does this sort of slow wobble. And do you see that slow wobble there? That's called precession. And spinning objects will tend to do this, and the Earth is a spinning object, and the Earth actually has precession as well. So even though it's spinning around very, very quickly, over time, it will start to slowly wobble like that, or it is slowly wobbling already. And this precession actually changes our view of the stars. So let's go back to our night sky here. Now, right now, the North Pole is sort of the top of that top where the Earth is spinning around. And the North Pole, as we know, is pointing right at Polaris. But as the Earth precesses, the North Pole will actually change which star it's pointing at. And I think I can show you that precession. Let's see if I can easily find... There it is. Okay, so right now the North Pole is pointing pretty much right at Polaris. Not exactly, but pretty close. But over the course of about 25,000 years, the Earth does this wobble, and it wobbles around in a circle. In about 12,000 years, the Earth will have wobbled to the point where the North Pole will point near Vega, and Vega will be the North Star, or at least the brightest star that's close there. So it's kind of crazy to think that even 2,000 years ago, Polaris was not the North Star. There would have been a different North Star because our night sky was different. But the thing is, our solar system, the plane of our solar system, is a lot more, what's the word I'm thinking of? Static, I guess. It's going to stay the same and not be influenced as much as, say, the wobble of the Earth is changing. So, in a sense, the relative positions of the Sun to the stars and all the planets to this background stars should stay the same, although our perspective on the night sky will change, if that makes sense. Because the ecliptic just marks out the path that the Earth takes as it goes around the Sun. And that path is not changing as much as the wobble changes. And I'm pretty sure, I may have to do some more research, and maybe we'll dive more into this on Friday, because I don't know exactly off the top of my head how much we know if we know, or how much we know about the orbital path of the Earth changing, that's affected at all by this precession that we see on the Earth's axis. That's a really good question, Eric. Thanks for asking that. So we'll put a pin in that, and hopefully I'll have a better answer for you next time, or at least confirming my assumption. So that is our early evening sky. Of course, now if you stay up later in the evening, you'll see even more stars and constellations, and we can fast forward time here to see the whole summer triangle rising. You'll also be able to see the outline of the Milky Way later in the evening. Summertime is the best time to look at the Milky Way because in the summer we can see the core of our galaxy where it's brightest and densest, shining in the south. Spring is not a great time to see the Milky Way because it's close to the horizon and obscured by our atmosphere. But like I said, staying up late, you'll see even more things in our sky. And another thing you'll see if you stay up even later, or if you get up very early in the morning, are a few planets. So there are 3 planets that are lined up nicely in our southern sky. We have the planets Jupiter, Saturn, and Mars. They're lined up quite nicely. And now Mars is moving away from Jupiter and Saturn, but Jupiter and Saturn are getting closer together. And over the course of this year, Jupiter and Saturn will be approaching a conjunction where they will appear as close as they get in our night sky. That conjunction, the Great Conjunction, is on December 21st, I believe. But this whole summer and fall will be a sight to behold as these 2 planets get very close to each other, an event that only happens every 30-ish years as these planets orbit at their own paces, and they orbit very slowly. So pretty cool to see these planets so close together. And this is the early evening sky, but we can time travel here, and let's just time travel over to, say, September. And so I've just bumped us to September, and I just wanted to see if so now we're going to look at our early evening sky in September, and you can see that as the year goes on, you'll actually be able to see these planets in the early evening sky. So don't worry about missing out on these. You don't have to wake up early right now if you don't want to. You can just wait a few months and you'll be able to see these. Now it looks like they're farther away from each other. That's because another weird thing that Jupiter and Saturn are doing is they are going in retrograde, which is just a very weird interaction between the Earth's position moving and planets' positions moving. And I'm actually going to try, just while I'm talking about it, I'm going to try to find a graphic to show you what I mean by this. Yeah, this seems like a pretty good one. All right. Oop, there we go. So, oop, no, I'll move this one. There we go. All right, so here's a little very, very basic animation showing retrograde motion. So basically, as the Earth moves more quickly than further away planets like Jupiter and Saturn, there will be a brief period of time where the angle between our planets will make it look like one is going sort of backwards. And this is called retrograde motion. You'll hear that mentioned in astrology a lot. People who practice astrology will assign significance to that. But this is just geometrically what is actually happening and why the planets appear to be going backwards. And so that's why Jupiter and Saturn appear a little bit further away. But if we time travel again, actually we can time travel straight to December 21st, where we can see that great conjunction. And so let's fast forward and see if we can find these planets. I might have missed them in the early evening. Let's go back. Oops. Yeah, so this conjunction, I accidentally pressed the button that took us back to present day. All right, let's just manually do this. Okay, yeah, so right at sunset on December 21st. Now, I've got Saturn highlighted here, and you might not be able to see Jupiter. Well, that's because they are right next to each other. So let's go ahead and zoom in. Way in, and you'll see they will appear right next to each other. In fact, with a decently powerful telescope, you'll be able to see the Galilean moons, the 4 bright moons of Jupiter that Galileo saw through his telescope, as well as the rings of Saturn. This is the proportional scale. So with the right aperture, you'll be able to see all these things in one telescopic view for that day only. So mark your calendars. That'll be very exciting. The great conjunction between Jupiter and Saturn, December 21st. But for now, we are brought to the conclusion of our stream. I saw we got a question from Sarah asking about the Starlink project. And I did talk a little bit about that on one of my streams last week. But the Starlink project is an effort by the company SpaceX to send over 1,000 satellites up into space to create a global network of satellites that could provide internet to places around the world that don't have access to the internet right now. There is a lot of criticism from the astronomical community because these satellites are very bright and shiny, and there's concern that if there are 1,000 of them in the sky, they could disrupt astronomical viewings. SpaceX is attempting to lower the albedo of these satellites, which is to make them less shiny, basically change the paint that they use to make them less reflective. These often pop up in the news after a Starlink launch, where they launch about 60 at a time. They'll appear in a bright line of bright dots all following one another, and you'll be able to see them really, really brightly in the sky. The reason they're so visible right after a launch is because they haven't ascended to their orbiting altitude yet. So as they get further away, they won't be as bright and visible to the naked eye, but there is still well-founded concern in the astronomical community. I won't profess an opinion about either because I think there are pros and cons and arguments to be made for the value of internet access around the world and the value of access to clear night skies for astronomers. So I'll let you decide for yourself. There is a lot of research and articles about that you can read, but that is just sort of a view of both sides of the Starlink sort of debate. But yeah, thanks for asking that, Sarah. If you ask any other questions, and if we've missed them during this stream, we'll write them down and be sure to bring them up on Friday for Fan Friday. Don't forget Wednesday at 6 p.m. to tune in for our stream where I will be assembling a telescope, and I will be teaching you about how telescopes work, best practices for using them. Again, I'll be putting together a reflecting telescope using an equatorial mount, but if you have any permutations, if you have a refracting telescope or an altitude azimuth mount or some other Schmidt-Cassegrain, other mix and match of that, then you'll still learn something about telescopes, I hope. Or you can see me fumble with trying to make this crazy live stream setup work in this pocket dimension that I've been trapped in for the past 9 weeks. But tune in for that on Wednesday at 6 p.m. and then Fan Friday at 6 p.m. this Friday. For now, though, I wanted to thank you all again for joining me for this fun live stream. I always have fun doing these. And I hope to keep doing them in some capacity when we do finally reopen and we're able to go back to the stars of the planetarium. Don't forget, though, for now, while we are working from home and while we are all limited with how we can reach out and resources we have right now, please consider helping out in any way you can, whether it's to recommend these streams to a friend, liking and subscribing to the Planetarium Facebook page. Any little bit counts. Recommending us to a friend is a huge thing to spread the word. And planning a visit sometime to the actual planetarium. And of course, if you do feel like you would like to donate to us, there should be a link on your screen to donate directly to Union Station. And you can become a member as well, and there are a lot of member benefits that, of course, will happen once we reopen. A lot of different ways you can help out, and every support you can helps a lot. For now, though, I will look forward to seeing you all on Wednesday at 6 p.m. Here's another link. You can go to unionstation.org/donate if you would like to find more information about donations and tax deductibleness, things about that. But this has been Patrick Hess, your planetary specialist, signing off for another live stream. Thanks for tuning in, guys. Again, guys, see you on Wednesday. Have a great evening.